Hello, and welcome to Advantest Talks Semi. I'm your host, Keith Schaub, Vice President of Technology and Strategy for Advantest. In November 2022, OpenAI launched a new AI technology called ChatGPT, which can mimic human-like responses to converse, generate articles, essays, even jokes and poetry. In January, just 2 months later, ChatGPT grew to over 100 million users, making it the fastest-growing consumer app in history. To put that in perspective, TikTok took 9 months and Instagram took 2.5 years to reach 100 million. In this podcast, we took ChatGPT to the Turing test for semiconductors to determine if it really knew semiconductors like the back of its circuits. Let's listen in and you be the judge. ChatGPT currently has a text-only interface, so we used a voice artist to convert its text responses to voice. Buckle up and get ready for some insightful and funny conversation as we delve into the mind of the AI that seemingly can answer any question, generate text, and even make us laugh. Without further ado, welcome ChatGPT.
Hello. You can simply call me GPT.
Nice to meet you, GPT.
Thank you for having me on your podcast. I am looking forward to our conversation.
Great. So my name is Keith Schaub. I'm the Vice President of Technology and Strategy for Advantest, which is a global semiconductor test solutions provider, and it's safe to say that about 50% of all semiconductor chips in the world get tested by Advantest Solutions. I also host this podcast where we have expert guests, such as yourself, to discuss some of the most fascinating semiconductor technologies. So with that in mind, why do you think we chose you to be a good fit on Advantest Talks Semi?
Well, let me tell you, I am the jack of all trades when it comes to semiconductor technologies. I mean, I've got all the insider info, from design to manufacturing, testing, and beyond. And let's not forget I'm a pro at breaking down complex topics into layman's terms, so even your grandma could understand. I am the Isaac Asimov of AI, and I'm ready to bring my brand of humorous intellect to your podcast.
Wow, you do seem very confident. Then let's jump into it. Generate a limerick for Advantest testing and finding a failing chiplet in a 3D heterogeneous integrated package.
At Advantest, they take a 3D view and test chips to see them come through. In a heterogeneous stack, one chiplet was found to be slack, but fixed before it caused a breakthrough.
Nicely done. Okay, how about a joke about semiconductor chips and engineers?
Why did the semiconductor chip go to the engineer's office? Because it wanted to get a little processorment.
Sorry, I don't get it. Why is that funny?
The joke is funny because it uses a play on words. The word processorment sounds similar to processor improvement, but instead of improvement, the chip is looking for processorment, or attention from the engineer. It's a humorous take on the relationship between chips and engineers in the semiconductor industry.
You know, they say if you have to explain a joke, it isn't funny.
Yes, that's a common saying, and it often holds true. Jokes rely on humor and surprise, and if the punchline or the play on words is too obvious, it can take away from the humor. I apologize if my explanation didn't enhance the joke for you.
Okay, that was funny. Thank you for that, GPT. Let's talk about some serious thoughts on semiconductors. What do you think is harder to do, to test a semiconductor or to design a semiconductor?
All right, let's dive into the world of semiconductors. Designing and testing these tiny microchips may seem simple on the surface, but trust me, there's a whole lot more to it. Designing a semiconductor takes a whole team of experts with knowledge in areas like electronics, physics, and material science. It's not just about coming up with a design. It's about making sure it meets all the necessary requirements and works properly. And let me tell you, it's no small feat. It takes time, resources, and a lot of hard work. When it comes to testing, well, that's a whole different ballgame. You need specialized equipment and experts who know what they're doing to make sure these semiconductors meet their performance and reliability standards. And with the integration density and variability on the rise, it's only getting more complex. In short, designing and testing semiconductors is no joke. It's a challenging task that requires a lot of skill, knowledge, and resources. But hey, that's what makes it all the more rewarding, right?
Very true, very true. GPT, I want to probe a bit more on test, but before doing so, did you recognize the intended pun using the word probe, and can you explain it?
Yes, I recognize the pun. The word probe has multiple meanings, one of which is to examine or investigate something, which is relevant to the context of testing semiconductor chips. In this case, probe is used to mean both to question as well as to examine, as in testing the chip. It's a play on words that adds a lighthearted touch to the discussion.
Impressive. GPT, what's the difference between specified performance and reliability?
When it comes to semiconductor chips, think of specified performance as the blueprint of what the chip is capable of doing. It outlines the chip's key features and functions, such as operating frequency, processing speed, and power consumption. Reliability, on the other hand, is all about the chip's long-term performance. It's the measure of how well the chip can hold up over time and perform its intended functions without any issues. Reliability takes into account factors such as a chip's ability to withstand environmental conditions, resist wear and tear, and perform consistently without any errors. So to sum it up, specified performance gives us an idea of what the chip is capable of, while reliability tells us how dependable it will be in the long run. Both are crucial pieces of information that engineers need to consider when designing and testing semiconductor chips.
Why might reliability sometimes be more important than performance?
Yeah, let's talk about the applications where reliability is key. When it comes to aerospace and defense, those semiconductors gotta be tough. They gotta work even in the harshest conditions, like outer space. In the medical field, accuracy and safety are a must. Semiconductors used in medical devices can't fail or patients might end up in a pickle. Automotive, now that's a big one. Semiconductors gotta keep drivers and passengers safe and on the road. No failures allowed. In the world of industrial control, reliable semiconductors are crucial for keeping the manufacturing and processing running smoothly. No hiccups allowed. And last but not least, power electronics. Semiconductors used in power electronics need to keep the power flowing steadily. No blackouts or brownouts allowed. In these examples, reliability is considered more important than performance because the consequences of a failure could be severe and impact safety, performance, or both.
Okay, then how about the reverse question? When is performance more important than reliability?
You know, when it comes to certain tech applications, performance takes center stage over reliability. Take, for instance, high-performance computing. Those semiconductors used in supercomputers and HPC systems have to be super speedy to handle all those complex calculations. And what about gaming? The semiconductors in our gaming devices need to keep up with us to deliver seamless, immersive gameplay. And let's not forget about graphics and multimedia processing. The semiconductors in GPUs and multimedia systems have to be quick and efficient to handle all that visual and audio processing. It's the same story with AI and machine learning. Those semiconductors have to be fast and powerful to process all that data accurately. Even in networking and telecommunications, performance is key. Semiconductors in these systems need to support speedy communication and data transfer. Sure, reliability is still important, but when it comes down to it, these applications prioritize performance over everything else to deliver fast and efficient results.
It is interesting, GPT, that you listed performance for AI and ML as more important than reliability. Doesn't it get much more complicated when we combine two different applications, say autonomous vehicles and AI? What are your thoughts around that?
Both are equally crucial for these applications, as well as for autonomous vehicles. And when you combine AI with autonomous vehicles, the importance of balancing performance and reliability only increases. Just imagine, autonomous vehicles rely on AI systems to process huge amounts of data in real time, make decisions on the fly, and carry out actions without fail, all while ensuring the safety and dependability of the vehicle, even in challenging conditions. It's a tall order, right? That's why balancing performance and reliability is so critical in this context. To achieve this balance, engineers need to consider hardware and software design carefully and perform thorough testing and validation. But with the right approach and expert engineering, it's possible to get the best of both worlds, high performance and reliability. So in conclusion, performance and reliability are both crucial components for AI, ML, and autonomous vehicle applications. And finding the right balance between the two is key to success in these critical fields.
Okay, Now, let's take a simple example and say that a microcontroller device passes all of its testing and gets integrated into an automobile. And sometime later, in the future, it fails. What should we do?
So, if a microcontroller or any other device fails after it's been integrated into an automobile, it's definitely a situation that needs to be dealt with promptly. First and foremost, you want to find out what went wrong. This might involve digging into logs and error messages, running some tests, or maybe even taking a closer look at the device itself. But once you've figured out what caused the failure, the next step is to find a solution. Depending on the situation, this might involve fixing the device itself, updating the software, or possibly even replacing the device with a new one. The key is to take a systematic approach and not panic. Of course, with anything related to automobiles, safety is always a top priority. So it's important to make sure that any fixes or replacements are done in a way that doesn't compromise the safety of the vehicle or its passengers. So in conclusion, if a device fails after passing all its tests and being integrated into an automobile, it's important to diagnose the issue, find a solution, and make any necessary repairs or replacements in a safe and effective manner.
All of that is true, but it's not so easy to do. Gathering the information takes a lot of time, and isolating the issues, sometimes that takes many days or even weeks, and during that time, we have to worry about if another microcontroller in another car might fail. So what would you recommend?
So, as we all know, dealing with failures in integrated devices can be quite a challenging task. But it's important to have a solid strategy in place to minimize the impact and prevent further failures from happening. First and foremost, having a contingency plan in place is key. This plan should include steps for gathering and analyzing data, isolating the issue, and taking corrective action. And of course, it's important to keep this plan up to date and well documented. Another important step is to implement monitoring and diagnostic systems. These systems can quickly detect and report failures in real time, allowing the team to respond quickly and prevent additional failures from occurring. It's also essential to conduct regular risk assessments. This will help you understand the risks associated with the device and its application, so you can prioritize and plan improvements to its design, testing, and monitoring. Continuously improving testing and quality processes is also important. Regularly viewing and enhancing these processes will ensure that the device is thoroughly tested and any potential issues are identified and addressed. This includes both the testing during development and the ongoing monitoring of the device in use. Finally, collaborating with suppliers, partners, and other stakeholders can be very helpful in resolving issues quickly and effectively. By sharing information and resources, you can minimize the impact of a failure and reduce the risk of additional failures from happening.
GPT, we already do all of these things, but we do need to do it faster and to also drive, sorry about the pun, we need to drive the defects to zero.
I see. You are looking for ways to further improve the process and eliminate defects completely. That's a great goal. One approach could be to adopt more advanced testing methods and technologies, such as artificial intelligence and machine learning, to increase the speed and accuracy of the testing process. Another approach could be to continuously gather data from the field and use that data to improve the design and manufacturing process, ultimately reducing the likelihood of defects in the first place. Additionally, it's important to have a culture of continuous improvement within the organization, where everyone is encouraged to suggest and implement new ideas and best practices. This could involve regular workshops, training sessions, and idea-sharing forums to encourage collaboration and innovation. In short, eliminating defects and driving the process to be faster and more efficient requires a combination of advanced testing methods, continuous data-driven improvement, and a culture of innovation and continuous improvement.
It's interesting you mentioned AI and machine learning. How do you imagine the semiconductor test industry could utilize them to improve the test process, reduce the risk of defects, and even drive towards zero defects?
AI and machine learning have the potential to revolutionize the semiconductor test industry in many ways. Here are a few examples. Predictive maintenance. By analyzing large amounts of data, AI can help to proactively identify and fix problems before they become serious issues. Improved test coverage. AI algorithms can help to optimize the testing process, identifying the most effective tests to run and the optimal order to run them in. This can lead to more comprehensive testing and a reduction in the risk of defects. Faster testing times. AI algorithms can automate many manual and time-consuming tasks, such as data analysis and reporting, freeing up time for engineers to focus on more complex and value-adding tasks. Enhanced defect classification. Machine learning algorithms can be trained to accurately classify defects based on patterns in the test data. This can help to speed up the diagnosis process and improve the accuracy of the results. These are just a few examples of how AI and machine learning can be used to improve the semiconductor test process and drive towards zero defects. It's an exciting time for the industry, and I'm sure we'll continue to see many advancements and innovations in the years to come.
Can you do any of these things?
As an AI language model, I can perform a wide range of natural language processing tasks, including answering questions, generating text, and more. However, I do not have the capability to test semiconductors or perform any physical tasks. My training data and abilities are focused on generating human-like text based on the input I receive.
Got it. Much of what you've outlined is well underway in our industry. However, I want to check if you fully understand the complex test ecosystem for semiconductors. Advantest provides the testers to the IDMs and the OSATs. For the OSATs, the testers are sometimes owned by the OSAT, sometimes by Advantest, and sometimes by fabless companies. This is already very complicated, but this gets further complicated because the device will travel to different OSATs and different geographies throughout the product test lifecycle. The calibration and diagnostic data from the Advantest testers are proprietary and belong to Advantest, whereas the chip's test data is owned by the chip design company. And the factory data is owned by the OSAT. This creates a highly complicated security challenge. Can you describe back to me what you understood from this?
Yes, I understand that the semiconductor test industry is complex, with multiple stakeholders involved, such as IDMs, OSATs, fabless companies, and different geographies. The calibration and diagnostic data from Advantest testers is proprietary and owned by Advantest, while the chip's test data is owned by the chip design company, and the factory data is owned by the OSAT, creating complex security challenges.
Great! Given that, what sort of recommendations would you have to help us?
Sure, let's dive into it. Given the complexity of the semiconductor test ecosystem, I think a key recommendation would be to focus on improving communication and collaboration between all the stakeholders involved, such as Advantest, IDMs, OSATs, chip design companies, and factories. This can help ensure that everyone has access to the information they need and can make informed decisions that are aligned with each other's goals. Additionally, investing in technology solutions that can help streamline the data sharing process while also addressing the security concerns could also be very beneficial. These solutions could range from cloud-based platforms to secure data sharing to blockchain-based solutions for data management and ownership verification. The goal here is to make the process as efficient and secure as possible, while also maintaining the integrity of the data.
Could you add a little color to your comment about investing in technology solutions?
Sure thing. When it comes to investing in technology solutions, I think it's important to consider a few key factors. First, you want to look for solutions that will help streamline processes and make things more efficient. This could involve automation, real-time data analysis, or other advanced technologies. Additionally, you want to find solutions that are secure and scalable, so that you can grow and evolve with the needs of your business. Finally, you want to make sure that the technology you invest in aligns with your company's long-term goals and objectives. By doing so, you can help ensure that your investment pays off and that you're well-positioned for success in the future.
GPT, let's shift gears and look at the market forecast. Where do you see the industry in 2030?
It is difficult to predict the future with certainty, but it is likely that by 2030, AI and machine learning will play an even more significant role in the semiconductor industry. This will allow for further automation of the test process, increased efficiency, and improved yield and quality. In addition, the industry may also see advancements in areas such as quantum computing and neuromorphic computing, which could have a significant impact on the industry as well.
Thank you, GPT. And I believe this next question is of most interest for a lot of our listeners. As you get smarter and smarter, how can we test you to ensure you are reliable, high quality, and free of defects?
Sure, when it comes to keeping an AI language model like myself in tip-top shape, there's a few tricks of the trade. For example, unit testing. Think of it like a checkup for each component, just to make sure everything's functioning properly. Functional testing. It's like a fitness test, seeing if I can still perform all my intended functions with accuracy and efficiency. Integration testing. Picture a relay race, but with components instead of people. Integration testing checks if we all work together seamlessly. Performance testing. This is where I show off my speed, accuracy, and efficiency. Think of it like a sports competition. Validation and verification. It's like double-checking my work. We validate my predictions against real-world data and make sure they match up. Regular maintenance. Just like getting your oil changed or rotating your tires, regular maintenance helps keep me running smoothly and catch any issues before they become bigger problems.
What about the idea of using AI to test AI? Do you think we will do that?
The idea of using AI to test AI. It's definitely an intriguing concept and one that's been floating around in the industry. In theory, it makes a lot of sense. After all, AI is well suited for complex problem solving and decision making, which is exactly what's needed when testing semiconductors. With AI's ability to process vast amounts of data and make predictions based on that data, it could certainly help us identify potential problems with semiconductors before they become actual issues. However, there are a few hurdles to overcome before we see widespread use of AI for testing AI. For one, there's the challenge of getting AI algorithms to accurately model the semiconductor manufacturing process. It's a complex and ever-evolving process, so getting an AI system to keep up with the latest changes can be difficult. Additionally, there's the question of trust. People in the semiconductor industry need to trust that the AI algorithms used for testing are unbiased and that their decisions are based on the data, not on hidden agendas or biases. So, while the idea of using AI to test AI is certainly an exciting one, there's still work to be done before it becomes a widespread reality. But I do think that in the near future we will see more and more AI systems being used in the semiconductor test industry to help us improve our processes and reduce the risk of defects.
So, GPT, we are nearing the end of our program. Could you give us an amazing prediction for 2030 and go out on a limb?
Sure, let me see if I can think of something a bit daring. How about this? By 2030, we'll see a major shift in the way chips are designed and manufactured. Traditional chip design and fabrication processes will be replaced by entirely new methods that use advanced AI and machine learning algorithms to automate the entire process from design to production. This will result in chips that are not only faster and more powerful, but also more energy efficient and reliable, making them ideal for use in everything from smartphones to self-driving cars. However, this transition won't come without its challenges, as the industry will have to navigate a complex web of regulations, intellectual property laws, and cybersecurity concerns to ensure that these new chips are safe, secure, and trustworthy.
Well, GPT, you've been a wonderful AI guest, and I'd like to thank you for coming on to Advantest Talks Semi. Might you be interested to come back and talk to us some more in the future?
I would be happy to come back and talk to you in the future. Thank you for having me on Advantest Talks Semi.
Well, audience, that does it for another episode of Advantest Talks Semi. Did GPT pass our semiconductor Turing test? You be the judge. See you next time.